Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction. That means you cannot find in the world any single force. All forces must be in pairs. And each pair manage to be in balance and opposite to each other. In another word, if you calculate all the forces in the universe, the answer will be 0. A simple example. If you push the wall, you are creating a force. Naturally, the wall will fight back and push you by the same amount of force but in the opposite direction. If you try it now, you will feel the fight back force through your hand. But it's still confusing. According to this law, nothing's supposed to move from rest. But that is not true. I can push a chair or any other small objects and they all move. That means there are a little misunderstanding for this law. Let's take this good example. A horse is pulling a cart. Of course they move. We have seen that many times. But according to Newton's law, the horse is pulling the cart and the cart is pulling the horse back by the same force. So, how they are moving? Aren't they supposed to stay where they are? Some people will compare this to a box is been pulled from both sides. The box will not move if both forces have the same amount. But the situation on this box is not the same case as the previous example. Do you know why? This box is just one object which has been pulled by two forces. So, the total force that affects on this one object equals to 0. But for this example, there are two objects are affected by two different forces. In this case we need to analyze each object and the force affecting on it. The first object is the cart. It is true that this force comes from the horse. But it is pulling the cart, while the other force caused by the cart and pulling the horse back. But it is not affecting on the cart itself. That is why we don't count it here. So, for the first object is just a simple case. A force pulling the cart and it will move forward. Now, let's see the horse. A force is pulling the horse back. But they are moving in the opposite direction of the force. That's impossible. Let's look at the big picture. Are there other forces affecting on the horse beside the one that been caused by the cart? Yes. The horse is walking and it is pushing the earth back. And by Newton's third law, the earth is pushing the horse by the same amount of force with the opposite direction. Now we can see that there are two forces affecting on the horse. As a start, the horse must have a higher force than the resistant to change the rest state to motion. So the horse and the cart accelerate to a certain speed. Then the horse doesn't have to push that hard. It needs only the same amount of the resistance to neutralize both forces and move in a constant speed as Newton's first law detects. Actually, this resistance force is what make it hard to pull the cart. If there is no reaction, we wouldn't need a strong horse to pull it. By then you can pull the cart by your tiny finger. Let's go back the whole system again. We can see that each force has an opposite twin sister but they don't cancel each other because they are affecting in different objects. We have talked about each force of these except for the one that pushing the earth. What is going to happen now? Will the earth move by this force? Physically, yes. Any object pushed by a force, it will move in acceleration as we mentioned in Newton's second law. But because of its huge mass the displacement won't be noticeable. It is almost zero. Actually, Earth is being pushed by many small forces caused by people walking and machines moving. But they all are relatively too small to change the course of the Earth. That is why we usually pretend that the movement of the Earth is constant. To understand the physics laws, you have to look at the big picture to see things clearly. Because if you stay on Earth you will think just like the people in the Dark Ages.